All right. And section 4.3 begins a series of sections where we talk about different ways to show that a triangle is congruent. In the last section, we talked about congruent triangles being triangles where all of the corresponding parts are congruent. We have to know that all of the corresponding angles are congruent and all the corresponding sides are congruent. That took 6 things. Now we start to learn some shortcuts. That, hey, you don't actually have to know all 6 of those things in order to know that the triangles are congruent. But you have to know the right sets of things. And there's a few different options. So in 4.3, we're talking about what they abbreviate as SSS. It stands for the side-side-side congruence postulate. And here's what the side-side-side congruence postulate says. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So we have a picture here. Notice there's a single dash side on each triangle, there's a double dash on each triangle, and there's a triple dash on each triangle. So they have 3 sets of sides in common. That is a guarantee that that those 2 triangles will be congruent. Their corresponding angles will also have to be congruent. We don't actually even have to know it, because if I know those 3 things, I know the triangles have to be congruent. So they show it over here. So since AB was congruent to RS and BC was congruent to ST, this is a T here, it looks like an I guess. Apparently that's a T. And then CA was congruent to TR, that means the 2 triangles were congruent. So we have a congruent statement. So we're going to do a proof here. We have a picture, and we're going to prove that the 2 triangles are congruent. So we have 2 givens to start with. I'm going to actually fit both givens on the same line. Oh, sorry, KL. So segment KL is congruent to segment NL, and segment KM is congruent to segment NM. Those are both given. And if we look at the picture, KL had a single dash and NL had a single dash, so that one's already marked. KM has a double dash, as does NM. So they're already marked congruent. So we're 2/3 of the way to being able to use SSS. I have 2 pairs of sides that are congruent, but I don't have the 3rd pair yet. So we're done with givens, but if you look at the picture, do we know that their 3rd sides are congruent? Well, the 3rd side of this triangle is LM. The 3rd side of the other triangle is also LM. They're the same segment. They share that side. So of course it has to be congruent to itself. So that's my next statement, is that segment LM is congruent to itself. It's congruent to segment LM. So we can now say, if you want to put a triple dash on there, you can. We can now say that side's congruent to itself. But what's the reason? That was a property from early on. We've rarely used it since we had it, but that's the reflexive property. If something is congruent to itself. POC, because it's a congruence, property of congruence. At this point, I have 3 pairs of sides that are marked congruent, so I can use the side-side-side congruence postulate to state that the triangles are congruent. So triangle, and they already tell me what my proof statement should be. I'm trying to prove that triangle KLM is congruent to triangle NLM. And so we would just write, you could simply write SSS, side, side, side. Since we had 3 pairs of sides congruent, we knew that the triangles had to be congruent. Example 2 requires us to do some graphing. And we don't have a graph on here, but we can sketch one. I need to go to a positive 10 on the x-axis and to a negative 3 on the x-axis. Looks like my y-axis needs to go from negative 8 to 0, really. I think I'll be able to graph all of the points, plot all the points in that section. First, we're going to plot the points for triangle JKL. So J is at negative 3, negative 2. K is at 0, negative 2. And L is at negative 3, negative 8. if I'm anticipating what the question is going to be asking. They're probably going to ask us if these triangles are congruent. In order to find out they're congruent, we're going to have to check the length to the sides. So I want to know the length of those sides. So I'm going to go ahead and find those lengths before I even move on to the second triangle. From J to K was horizontal. They both had y coordinates of -2. So if it's horizontal, I can just count how many spaces. So from -3 to 0, I went 1, 2, 3. So JK is 3 units long. And then from J to L, that's vertical, so I can just count that one down as well. And I know that because J had an x value of -3, L had an x value of -3. They were the same, so they have the same x coordinates, so it's just straight up and down. So I'm going to count down from the -2 to the -8 on the y. So 1, 2, 3, 4, 5, 6. Looks like I'm going down 6. This would be a little easier to count if we were actually using a real graph. So be careful counting, but that's accurate. What I don't know, what I can't count quite as easily is from L to K because it's diagonal. We would have to use the Pythagorean theorem. Remember, horizontal and vertical are perpendicular to each other, so we do have a right triangle. So we'll do Pythagorean theorem here. I'm going to go 3 squared plus 6 squared. We just found those two numbers already. Equals, you can call it x squared if you want. So we got 9 plus 36, which adds to 45. I'm going to square root. Square root of 45 does in fact simplify. It does not become an integer, but I'm going to leave it like that for right now. I'm just going to write square root of 45 because I don't necessarily want to spend my time trying to simplify it, because all I'm going to need to know is if they're the same. So I'll check to see if the other one's square root of 45 as well. That'll be sufficient. I don't have to spend time simplifying that square root right now. So let's move on to the next triangle, triangle RST. So R is at 10, 0. S is at 10, -3. So from 10, 0 to 10, -3, that was 3 units. That was vertical. We can count straight down. And then T is over at 4, 0.
4, 0, you said?
4, 0, yep, it says. Tells us that up here. T is 4, 0. So from 4, 0 to 10, 0, that's going to be 6. 1, 2, 3, 4, 5, 6. And so then from T to S, we have to do Pythagorean theorem. Aren't I using the same numbers again? 3 squared plus 6 squared. I could write it down again, but I know it's the same number, so it's going to end up being the same thing. Square root of 45. Okay, so I should go back and actually read the question. I assume we've already answered, or we were able to answer it now. But it says graph the triangles in the same coordinate plane. Okay, we did that. And show that they are congruent. So here's how I would show that. So segment JK was 3 units. So was segment RS. So I can say they're congruent to each other. I had the JL was 6. So segment JL, well, that was congruent to RT, because that was also 6 units. And then lastly, the KL, that was the square root of 45 one, would be congruent to ST, because that was 45 also, the square root of 45 also. So all 3 sides are congruent. So therefore, I can state that the triangles are congruent. So triangle, name the first one, maybe JKL. Now when I finish my congruent statement, I need to make sure they're in the same order. So pay attention. We don't have angle arcs this time to help us name it. So we have to base more off the side. So here's what I would do. When you're looking at J, notice J is the angle, the vertex between the 3 and the 6. So over here, go between your 3 and your 6. Oh, that would be R. So J corresponds to R. K was the one between 3 and the square root of 45. So come over here, you look at 3 and the square root of 45, they intersect at S. So S is the second letter, and so then L, which is where 6 and square root of 45 intersect. So 6 and square root of 45 intersect at T over here. And we know that that's true by SSS. I had 3 pairs of sides congruent, so I was able to show that the 2 triangles were congruent using SSS.
Side, side, side.
Side, side, side. And that is the end of the notes. The assignment would be to do the problems on the back where you get some extra work on this. Just a reminder, like as you look at questions 1 and 2, they give a weird symbol, but that's supposed to just be an angle sign. So don't worry about trying to figure out what that symbol is. It just prints off funny. It's supposed to be angle.